One of the ways malware that's viruses get delivered is via documents exploiting Microsoft Office features. Today we'll take a look at what will help us while launching and performing analysis. We'll make use of Twitter threat intelligence. We will also analyze files with Virustotal and then check out some other tools. So let's get right in and see what we can do. Performing a generic query on the Twitter search button provides you a generic and randomized result that may not be tailored to your needs, as can be seen here. You can use Twitter Advanced Search to better fine-tune the results of your search. You can filter by all of these words, these exact phrases, any of these words. By hashtag, select language, tweet from an account, reply to an account in mention of an account, by replies, presence or absence of links, or by number of likes, retweets, and replies. You can also specify date range. I'll show you some examples in just a moment. This is very cool, something you can really leverage and have fun. For demo, we will be searching for malicious Word document exploiting the rich text file format. That's RTF in Microsoft Office. This is something we have seen prevalent in present day after Windows disabled the macro features, which was what attackers leveraged on before now. So they had to find a new means of attacking or delivering their payload. So we would pick malicious RTF as in there, and then we would select from what date range we want to find our samples from. We are going to pick, let's say, July. And then what date? Let's pick 17, just a random date, and the year 2022 will be fine. So to what date we'll pick from, and then to what date. So we are going to pick August. We are in August right now, and let's pick 2nd of August or 1st 2022. Then let's see what results we can find from there. Notice the search query, how it's structured on the search bar. Notice also that our search is more fine-tuned because we were a bit more specific with our query. So we get a much more fine-tuned result, which is relative to malicious RTF samples, what people have tweeted. So this helps us better than a more generic query we had used earlier, which was just RTF. We see results from Inquest Labs, we see results from Mr. And this helps us a lot because this is what we are looking for, and we will be picking one of the samples. But if we go to search by hashtag the word RTF, the acronym RTF, we see that we are also getting generic results, not specific. So when you encounter these kind of problems, you know you have to take a step back and then fine tune your result. Make it more specific so that it can yield you output that is filtered towards what you need or what you expect to see. So let's just go ahead and search for samples specifically from the account Inquest, and let's be noticed that they've been making a lot of tweets on RTF related malware samples, and have been doing research on RTF malicious samples lately. So this is always my go-to resource for relevant samples, present samples that are useful and that are live, because I get to download the next stage of the payload, because most of the times the C2 is still live at the time when they report these samples. So it's very useful. As they tweet, I get to see them, and it helps me in my research and in getting new samples. So I like them a lot. So with Inquest Labs, you can get a lot of useful information related to malwares. So what we'll do right now is we're going to pick one of the sample and then see what the report has. So let's open this in a new tab, and then we'll see what Inquest Labs has to report about this sample. So let's copy this. We'll be using it later when we are visiting Virustotal to check what the hash carries, and that's the next thing we'll do further research on Virustotal to see what the malware sample is capable of doing. So this is Inquest Labs. So from the report here from Inquest Labs concerning this particular sample, you see a lot of useful information that will help you gain initial footprint on the sample. We see deep file inspection, what it is capable of, the metadata concerning the malware sample or the file which they have analyzed and then updated us with the report. So we can see the file hash, the SHA-256, and we can see a lot of other useful things that helps us with the initial foothold and fingerprinting on what this sample is capable of doing. So if you scroll down, you can see some more meta information. You can see here the domains possibly related to the sample, and you can, without opening the document, you could see what it contains, and this gives you a fair understanding of before launching into, let's say, unleashing the sample in your lab to see what it will do. You have an idea what it is capable of doing before actually venturing into it. So these are all the things you would see, and you would see the time, the date related to the file when it was analyzed, when it was first submitted, and all of those things. You would see the names of the file, possible names, so that you could, when you are creating your Yara rule, you could insert this in your rule and know what to check or hunt for. You would see the indicators of compromise, and all of those things, they make it available in one report, and it arms you with a lot of information. So coming over to Virustotal, we see we can submit the sample by URL or file or search with the hash, and we've done that. So this is what we have. Out of, you see the number of antiviruses that has detected this as malicious, 27 out of 60 or 40. So we see the CVEs related to the sample, what exploiters are exploited as it leverages on, and you can also see that it is RTF related. Then these are the various antivirus engines that has detected this malware as this file as malicious, and a lot of times Virustotal provide you even with the Yara rules you could implement on your system, your endpoint, to watch or monitor for further indications of compromise in subsequent or future events should it occur. So it's a good way of amping your defense up. So you check the details. You can also see the file metadata, the MD5, the SHA hash, the SS deep, TLSH file type, and when it was first submitted, when it was last submitted, when it was last analyzed. So it makes you form an opinion on the time frame or the time span of this part of that this malware sample has been in the wild. Now, you on the comment side, you see what people posted concerning this. So let's go over to our Remnox labs and take this malware sample apart by ourselves and see what we can find. You use a cd command to change directory to folders. That this is where I store the sample I would like to work on. So I will change directory with the cd command to this directory folder, as you would like to call it. So I will also make another directory with mkdir, and I will call it let's use the date, so that I know when I analyze this. You can use whatever you want, you can call it whatever you want, but just for easy reference, I like to use that so that I know when I worked on this sample. And then with the cd command, I'll change the directory again to that folder. Command, we're going to fetch the malware sample from the URL which we found from Inquest. So this is the domain, the C2, where the malicious files are being uploaded. It's still live at the moment, and we can directly get it with wget download into our system and then see what we got. All right, with the ls command you can see what is in the directory, and let's clear this up and go ahead. So let's run the file command on the document and to inspect what kind of file we are dealing with, and we can see a report data. So let's run exif tool and see also what information we can gather about the file. And then this also does not tell us what kind of file it is. It doesn't indicate if it is RTF, but if you use DIEC, that's detected easy console, and on the file you see that the format is RTF, which is plain text. So we know we are dealing with an RTF related document. So if we use XXD, we can get the hex code of the file, which will indicate by the header that okay, this is RTF. Now remember, some point in Virustotal we saw this bad header stuff related. So this is what it meant. RTF normally it's supposed to come, there are specific orders where the header is supposed to come in, so but that didn't match up. So if you scroll down a lot and you see some more things related to the file, and right now we can't see anything really because a lot of things are obfuscated. So we need to take out the sample and then deobfuscate so that we can see what it contains, which is what we are going to do next. So running rtfdump.py on the sample, we get to see the extracted information from the file, which is before us, and then you see that these are higher bytes, higher length, so it indicates that there are a lot of possible data that are contained in this section, this level 1, 2, and 3 than others. But what we want to do right now is try to filter for the objects contained in this document. So with dash F and capital letter O, it means filter for the objects, and you see that it didn't return any object, meaning this is obfuscated. That's another proof that it is possibly obfuscated. With RTF obj, we can extract some further useful information about the file, and then if you run it on the document, we see that we don't have a well-formed OLE object, which is why we're not able to extract any object with the dash F and O filter. So let's clear this up. Even if we also try to filter for objects with dash F and capital O with this tool, we would also see we would not be able to extract any object from the file. So because there are no well-formed OLE object, so that's why we can't extract anything from it. The next thing we can do is see if we can, by selection of each level, either picking 1, 2, or 3, if we can make sense of the hex dump of the selected level. At least perhaps we can be able to decipher if there is something we can make sense of from this file, even at the most mundane level. But the way to do that is use the dash capital H and then dash S and select the level, which in this case we'll use 1 first, and then let's pipe this to head so that we get the first few bytes of the hex. So we see we can't make sense of whatever we get here. If we do it even on the second level, that's picking 2, we see that we also do not make sense of the hex value returned from this. And then even if we run that on the third level, we would also see that we don't make sense of what is returned. Very, very indicative of the fact that this is possibly obfuscated. So we can't make sense of the X, right? We can't make sense, but there are some things we can do. So let's use the dash D option to try to decode what we find here and save it to a file. This is what we decoded, and we wrote it to a file level 1.dat. So let's run file on it, and it's a data. Running xxd on it to view the hex byte, we see that we still don't make sense of what is here because it's not useful for us as it is. So let's run ZOR search on this with the option dash capital letter W and try to extract offsets in this level 1.dat file, which we can leverage on in our further stage of analysis. The next thing, we'll run scdebug and emulate the shell code and see dynamically what it will return to us. So we'll pick the file from the folder you want to inspect, and then we'll launch it, and then when prompted we'll pick index 1 or any number, and it will dynamically decode it for us. So we selected index 1 and it emulated the shell code, and then see the output what we get. Within this we can see already, okay, there is a URL which indicates the domain. We can pick or extract this domain URL and visit it by ourselves. Because the malware is still live, we can extract some more codes. So we'll visit the domain, copy it from there, and it brings us to this directory, web directory, and we see what's hosted here. We see coco.exe and we see the document we just inspected. And because the C2 is still live, normally by now it should have been taken down. Let's run wget to fetch coco.exe from the domain. This is the next level of the attack, the next stage, and with ls we can see that it's already here on our directory. And then with file, we see that this is a PE32 executable built for Windows. Using direct to further triage the file, we would find that this is a .NET library. So this is a .NET file. So let's launch this on die itself. With die, which is the GUI version of die, short for detected easy, let's check the strings of this file. Normally from the strings output of a file, you would be able to piece one or two indicators of a file to know its capabilities. So just running down, checking anything that would appear or pop up to me, something familiar, something that would probably hint me on what this malware is capable of doing. And I see some stuff. You can see a get password, right? So probably it's an info stealer. It's just an opinion. I've not looked at it. It's just an indication, and it's an opinion. It's an hypothesis. So digging further, you see some more things. You see cipher. Okay, you see a lot of stuff that will pop up to you and probably hint you on what this file is capable of. Probably it's left for you to dig in further and then see if this is actually right, if this is actually what it is, to confirm for yourself. So it will take a bit of reverse engineering, which I am not going to do that with this sample on this stream, probably some other day. And I love .NET malware because I get to see the source code and it's fun and thrilling to look at. So running down strings, you see some useful things, some useful hints that will probably tell you, okay, what am I expecting? What should I be looking at when actually reversing this sample? What should I be aware of when actually reversing this sample to know more about it? So you keep scrolling and scrolling and scrolling. You see get domain, you see a lot of stuff. Keep scrolling. It will also probably indicate to you if the malware is packed, if it is obfuscated, if it is a ransomware. What kind of malware are we dealing with? Is it a ransomware? Is it an info stealer? Is it a Trojan? All of those things. Is it a botnet? Sometimes you may be able to find the IP address of it is trying to contact. You would see a lot of things, possibly. So you keep scrolling, and it's sometimes a bit boring, So going back to detect it easy, we see the overall info of the file. If you check file, you see this is library.net 4.0, and we see that it is 32-bit, and then we see that it is packed. If you check the import section, you see that you can't make sense of whatever you find there, because the import table is actually empty, which shows you, okay, this is possibly packed. So keep checking some stuff. You check the heuristic scans, you check the image just header, just pop around on Diag with the file, with the sample you uploaded, and see if you can make sense of one or two, or try to understand the file some more. Try to understand or gain a deeper understanding of the sample you are potentially about to reverse engineer or to detonate in your network environment, which I would advise do this in your lab. Don't do this on your regular system. You will set your whole house on fire, and that's not cool. So this is just me running down the disassembly, the hex code of the binary, and just perusing through stuff to see if I can make sense of anything I can find here. Now, you see the entry point, you see base address. Now let's check the entropy. You see it is 97% packed. Okay, so Detect It Easy can tell you if a file is packed or not. So we see here that the PE header is not packed, but the section.txt header is packed, which is where the code and the instruction is normally contained. And you see the graph presentation. I don't really understand what this is at the moment, but it further hints you on based on entropy if the file is packed or not. So that's that. So this is where we will stop for today. I hope you've been able to pick up one or two stuffs. I sure would love to hear from you in the comment section. Thank you for watching.